Hello out there. I'm referring to this task on Graphisoft community using GDL to write parameterized iron changed, and Youngler made really some good solutions for it, but I thought it would be good to think about it in another way. So let's have a look at it. I thought it would be good not just make something in equal distances for mathematical curves. I wanted to make something to achieve this on every, and I did. You see, here is the distance that should divide the polygon wherever it is. You see how it does, and make some special things. So now I have a very short distance for the first segment, a longer, a shorter, and now I make my repeating distance larger. You see, 2 times, 1 time. It goes over the point. I'm talking about this here. It goes over the point, the distance from here to here to here, and so on. So it follows every polygon, no matter what geometry is on it. So it should be possible to do every polygonal structure. Doesn't matter if it's mathematically or manually built. You can divide it. This is just for me to understand what I have to do. For GDL, I should open it. It does the following. I did this with the polygonal structure from Esteban Ramos. It's rather old now, but I couldn't do something like this. But in the master script, you can add points and so on. But what I did, I took this thing from Esteban Ramos. Let's have a look at it. And it gives the polygon in these 2 parameters, which are counting up. So from this here, I did the following. First, I made an editable hotspot that I could change easily the distance, this here. And then I went to the calculation of the needed spots. First, I did some dims so that I had these parameters. Then I calculated from the full length from Esteban Ramos through this one. How oft is the word for often in German. How oft it should make it. Then, first, I go to the original polygon and I calculated this thing for every point, how far it's the real distance to the 0 point. And another one before. So one distance shorter. So this here gave me the possibility to see what I'm doing. These are the little larger spots here. So if I make this longer, you see this is changing. And now you see, but I do it a little to the side that you can see it. This distance, this Abstand in German, this distance is following here. And I had to look in which segment this little following Abstands points are. You can see it here. It's segment 1, segment 2, segment 3. So how did it? The second, I did it the same as I did here. This here. The same for the new points. This is the length of the new points to the beginning for every point. So I had two things that I could compare. This one and this one. And additionally, this one. So, in the next step, I looked where every of my new points, in which segments they are. Wo bin ich is where I am in German. And I begin with the first point. I just wrote it in a new parameter to get it a little bit easier to read. And then I went from 2 to points to at 1. The points are the number of points of segments of Esteban Ramos polygon. The upper distance, the distance below, and the if, where it sits. And then, wo bin ich, where I am, is the number. And then I gave it in the next parameter following. So I had for every point where in which segment of the original position it is. This is this text here, this one, so that I could see it. Next step. For every new point, I just calculated the width within one segment for every point. Here. Then the angle. And so I could do for every point from the original point plus this one, cosinus and sinus. I got every new point and I got this circle. This is this circle here for every segment of Esteban Ramos polygon. So this could be taken to other things. Maybe something like, where is it? Okay, here. This one. Okay. So maybe you know my older things to get something to work like this, but on a parable it was mathematically for me not possible to calculate equal distances. But with my new function, I did it in the master script here. It's the same like on the other ones. What I just added was the angle here, the calculation of the angle of every new segment, so that the change segments would follow in the right direction. So here. So it doesn't matter what the original polygon distant points are. It just calculates new distant points linear on each segment for something like this, or something okay, better. Okay, here it is. For something like this, you can think about making some new brick bounds here, and it's still following wherever you go. And go back to the GDL 3D script, make the dims. Where are they? Ah, die sind in master script, glaube ich, oder? No, here, the dims. Then coordinate from Esteban Ramos. Then calculations. I took the old name. That's not calculations, that's cylinders, but I took these names. And then I just what kind of curve. It's only in the parabola now. And if I do it as rope, go to rope. If I do it as a brick followings, bricklayer work, do it this. And if it's a chain, do this. It's just a chain, just taken from, where it is? From this one, from Jongler, and I just named it a little bit other. And this is the first. This one. This is yes, it's the same function like the chains. And then here master script, go to the master script, the calculations, just from Esteban Ramos. Then my calculation from the other GDL, the Abstand, the distance of the new polygon. For the bricks, I just took the broadness of the bricks and the mortar, and then full length without one mortar part, and then integer how often of the full length with this calculated, and then calculate this distance new, that it always suits the full length. And then this is all the same until the part of the angle which is needed for every point. In 3D script, that's just all for it. If it's a chain, if it's bricks. That's all. So what could be done with this new function? With the extras, the goodies add-on, you call it in English, the goodies add-on can also follow the polygonal structure of maybe walls, maybe roofs, and maybe slabs. And you can also divide this into equal distances for some purposes you can imagine by yourself. Okay, that's just a beginning of the usage of something like this. By the way, what I did in the chain to get it a little more natural, here. So, if you look down the chain, it turns a little bit. What have I done? If it's a chain, every little chain part is changing directions about 5 degrees or 10 degrees or 2 degrees. This is this one and this one. So it looks a little bit more natural, I think, what I could look. So that's all for today. I hope you can use it for yourself. Have a nice day. Greetings from Lake Wallersee in Salzburg in Austria in Europe.